In this video, I'm going over some practice problems on multiplying and dividing rational expressions. So in this first problem, notice how we're given in function notation our two rational expressions here. And according to the function notation, with this fraction bar, we are dividing. So remember, right, this is because of dividing, we are going to do our keep, change, flip. So here, f of x is a squared plus 15a. And we are dividing that by g of x, which was the a squared minus 4a. Now, when doing keep, change, flip, remember, right? Keep that first rational expression when dividing. So I'm going to keep. Now multiply by flip, right? The reciprocal. So now it's a plus 8 over a squared minus a minus 42. Now we can start multiplying straight across, but before we do so, let's go ahead and factor. I notice in my first numerator, I do have a trinomial, and because a is 1, I can go straight to parentheses. So what numbers multiply to give me 54 and add to get me 15? 9 and 6. Then here, I've got a plus 8. Well, nothing I can do about that in terms of factoring. So when we multiply straight across, we're going to have those three sets here, three sets of factors. So a plus 9 times a plus 6 times a plus 8. Now in the denominator, I notice here in the first denominator, we do have a GCF. I have a GCF of 6. So now when taking that out, now I've got a plus, well, 54 divided by 6 is 9. Then the second is a trinomial. A is 1, so I can go straight to my parentheses, where what numbers now multiply to give me negative 42 and add to give me negative 1. Negative 7 and positive 6. So now multiplying straight across, I'm going to leave everything here in factored form in my denominator. Now I can start canceling out those common factors. So I notice I have a plus 9 and a plus 6. My final simplified answer is a plus 8 over 6 times a minus 7. Now looking at the second question. Again, we're given function notation, f of x and g of x. But notice now we are multiplying the two functions. So I'm going to set up my f of x, which is just x squared minus 4. And we're going to multiply that to g of x, which is that x squared minus 12x plus 35. Now, do we need to do keep, change, flip? No, because we're already multiplying. So I'm going to go ahead now, before I start multiplying straight across, right? Go ahead and factor. Can I factor x squared minus 4? Yes, because that's a difference of two perfect squares. I can take the square root of x squared, which is x, the square root of 4, which is 2. So that's x plus 2 times x minus 2. Then the second is a trinomial, and a is 1. I can go straight to my parentheses here, and what numbers multiply? Oop, I put a's there, sorry about that. What numbers multiply to get you 35 and add to get you negative 12? Negative 7 and negative 5. So now I'm just going to rewrite it because I'm multiplying straight across, keeping in factored form for when we have to start simplifying. Let me go ahead and extend that. Now let's focus on the denominator. Well, notice here I've got x minus 5. Can I factor that? No. That's just a normal binomial. So I'm going to leave that x minus 5. Here we do have a trinomial. A is 1, so I'm going to go straight to parentheses. What numbers multiply to get me negative 14 and add to get negative 5? Negative 7 and positive 2. Now I'm just going to continue in factored form, multiplying straight across. So that x minus 5, don't forget about that, and x minus 7 times x plus 2. Now start canceling out. I see I've got x minus 5, x minus 7, and x plus 2. So the final answer is just x minus 2. Because here nothing was in the denominator except for 1, so again it's just x minus 2. In this question, we are dividing our two rational expressions. So because we're dividing, I do need to do the process of keep, but change, and flip. So multiply by the reciprocal. So we're going to keep that first rational expression, our 2x squared, but now multiply that by the reciprocal, flip it. So now it's x squared minus 1 over 6x plus 15. And now we can start factoring as we multiply straight across. So here the first numerator, our trinomial, but I can't go straight to the parentheses yet because we have now a is 2, which is greater than 1. Do I have a GCF that I can divide all three terms out by? No. So we do have to do bottoms up. So I'm going to show my work over here. So x squared plus 11x, but now plus 30, right? Because from 15 times our a here, 15 times 2. Now when I factor, what numbers multiply to get me 30 and add to get me 11? 6 and 5. But remember, because of bottoms up, we originally started with 2x squared here. Whatever our a was, which in this case is 2, make sure now to divide by 2. So 6 divided by 2 is 3. So here I've got x plus 3, then bottoms up, because I can't simplify, right? 5 over 2. So 2x plus 5. Now the second here, second numerator, can we simplify or factor? Yes, because it's a squared, and it's the difference of two perfect squares. So now here, I've got the square root of x squared, which is x. Square root of 1 is 1. So x plus 1 times x minus 1. So I'm going to now go ahead and rewrite this. So x plus 3 times 2x plus 5, but then times that second numerator. Now going into the denominator. Notice how this, though, notice the difference, right? That's not x squared minus 1. That's just x minus 1. That is not a difference of two perfect squares because that's x squared here. So this stays. Nothing I can do about that. I cannot factor x minus 1. But we can factor the second denominator because between 6 and 15, they have a GCF of 3. So after taking out that 3, 6 divided by 3 is 2. So 2x plus 15 divided by 3 is 5. I'm going to put that GCF here out front. So 3 times x minus 1 times 2x plus 5. Start canceling out our common factors. Here I've got x minus 1 and 2x plus 5. So our final answer in the numerator is x plus 3 times x plus 1 over 3. Now that's the answer in factored form. I could also, with the numerator, do box method or FOIL that out to get our new numerator here as well over 3. So question number 4, notice how, again, we are given in function notation. I've got f of x and g of x. And again, from our function notation, notice how we are multiplying. So I have f of x first, so that a squared plus 2a. And we're multiplying that by g of x. Now, do we need to do keep, change, flip? No, because we're already multiplying. So I just need to multiply straight across my numerator and denominator. But first, let's factor. First, we have our trinomial and a is 1. I'm going to go straight to my parentheses. What two numbers multiply to get negative 8, but add to get 2? Positive 4 and negative 2. Then here, that's just a minus 9, not a squared minus 9, just a minus 9. So I cannot factor this. This stays as a minus 9. So when we multiply, let's leave everything in factored form and then times a minus 9. Then the denominator. Can I factor a minus 2? No, that stays as a minus 2. Nothing I can do about that. Here I just got 6. So this is 6 times a minus 2. So as I now cancel out, I can cancel out a minus 2. So now I'm left with, in my numerator, a plus 4 times a minus 9 over 6. Then, of course, I could do box method and FOIL this to get this no longer in factored form and also have my answer here. In this next problem, it says that Susan simplified a rational expression and got it to be this final answer. So which of the following could be that expression that Susan simplified? Well, in A, I'm going to go through. I notice everything's in factored form. I do have common factors here of x minus 5. So this is 7 times x minus 2 left alone here, which if I were to distribute, there is 7 times x, which is 7x, and 7 times that negative 2, which is negative 14 over, but just x plus 3. But I need both still with that x minus 5. So A is not my answer. Now let's go to B. Well, I notice here in the numerator, there is a difference of two perfect squares that needs to be simplified. So I'm going to rewrite this. So 7 times, that is difference of two perfect squares. So x and then the square root of 25 is 5. So x plus 5 times x minus 5, and then continue because I can't factor x minus 2 over x plus 5 times x plus 3. So now notice here, I could cancel out my x plus 5, but then that's it. Now notice here, I've got 7 times x minus 5 is in the numerator, not the denominator where we need it to be. So B is not my answer. Now let's go to C. Well, notice here we're multiplying. So that's just multiplying straight across. So here I've got just 7 times x minus 2. So that is, again, if I wanted to distribute, there is 7x minus 14 over multiplying. Can't factor those, so it stays as x minus 5 times x plus 3. Notice C matches. So just to show if anybody chose D, why D is not the answer. Notice how we're dividing, so we do need to use keep, change, flip because we're dividing. So I'm going to keep 7 over x minus 5, but multiply that by the reciprocal, which is now x minus 3 over x squared minus 9. So now notice here, I've got multiplying straight across. So that's 7 times x minus 3. Well, that gives me 7x, but now minus 21, not x minus 3. But you know what? I just realized too, let me go ahead and continue with the factoring because in C, they had no common factor. So I'm going to leave this in factored form. So 7 times x minus 3 over, can't factor x minus 5, but I can factor x squared minus 3, x squared minus 9. So I've got x minus 5 in my denominator, but then here x squared minus 9 is x plus 3 times x minus 3. Now the x minus 3's cancel out, and the denominator matches x minus 5 times x plus 3. But notice how you only have 7 left, and I need 7x minus 14. So that's why it's not D, and the answer was C. Question number 6 was asking, what x values make this rational expression f of x undefined? So, or extraneous solutions are the extraneous solutions, and we're selecting 2. You have to remember what makes a fraction undefined. Any value, it could be any number, any variable, but you cannot divide by 0. So our denominator, the original denominator, cannot equal 0. So we are basically solving 3x squared plus 11x plus 10, but not equal to 0. And then we can solve this by factoring. But I can't go to the parentheses yet, right? Because a is greater than 1. A is 3. So do we have a GCF? No. So we do have to do bottoms up, multiply a times c. So x squared plus 11x, but now plus 30. Now I can use parentheses here. What numbers multiply to get you 30 and add to get you 11? 6 and 5. But again, is this my answer? So x is not equal to -6 and -5. No, because of bottoms up, remember, right? Whatever a was, in this case 3, whatever you multiply by, now divide by 3. So now here I've got x plus 2 from 6 divided by 3, and then bottoms up times 3x plus 5, but not equal to 0. So we're going to still solve this as if it's equal to 0. So here, remember, right, change the sign. So if it's x plus 2 is not equal to 0, then x cannot equal negative 2. So that is one of our solutions here. We also have 3x plus 5 cannot equal 0 and solve for x. Subtract 5 and 3x cannot equal negative 5. Divide by 3 and there x cannot equal negative 5 over 3. So that's why here both the answers B and C are what make this undefined. Also that shortcut, and I know some of y'all have noticed that pattern. The pattern is from bottoms up. Here's your fraction here. So if it was positive 5/3, remember, because we're solving, change that sign now to negative 5/3. In the next question, it says we are given the length of the rectangle is represented by this expression. So this is the length. And then we have the width of the same rectangle is represented by this rational expression. So this is the width. We are finding what? The area. So how do you find area of a rectangle? Well, area is just equal to length times width. So if we're trying to look for the area, then what do we have to do? Multiply our two rational expressions. So we are multiplying 4a minus 16 over a minus 2 times our second rational expression, a squared plus 3a. So now because we're multiplying, do we need to do keep, change, flip? No, because we're multiplying. I'm just going to multiply straight across my numerator and my denominator, but of course factor. Can I factor the first? Yes, because you have a GCF here of 4. So after taking out 4, you're left with a minus 16 divided by 4, which is 4. Then here I've got my trinomial, a is 1. I'm going to go straight to parentheses. What two numbers? Multiply to get you negative 10 and add to get you 3. Positive 5 and negative 2. So as we multiply right straight across, the leave still in factored form. So 4 times a minus 4, but then times our second. Now let's go to the denominator. Can I factor a minus 2? No. So that's just a binomial that cannot be factored. So I'm going to leave it a minus 2, and then that's just times 2. So I'm going to put my GCF in front. So 2 times a minus 2. So now I see I can take out a minus 2, cancel that out. And really, I also have 4 divided by 2. 4 divided by 2 is 2. So I've got 2 over 1, which is just 2. So here we've got our final expression. The area is 2 times a minus 4 times a plus 5. Now, if I wanted to continue, instead of just leaving in factored form, I could multiply this out using box method, but then make sure to also distribute and multiply that final by 2. So question number 8. Here it says the area of the rectangle is represented by this rational expression. So now this is the area of a rectangle. And then the length of the same rectangle is represented by this expression here. What we are looking for is the width. So we know that area is equal to length times width. However, we're not looking for the area. The area was given to us. We are looking for the width. So that's why in this case, this is division. So we're going to divide to solve this problem because you would have to divide by that length to solve for the width. So we have area divided by that length here. So I have my area, which is 7x plus 28. And we're going to divide that by the length, which is that's 7 over x minus 6. Now, before we get started, do we need to use our process of keep, change, flip? Yes, because I'm dividing two fractions here, two rational expressions. So I do need to keep that first rational expression, but change the second to its reciprocal. So I'm going to keep 7x plus 28. But now multiply that by x minus 6 over 7, reciprocal. Now we can go ahead and get started multiplying straight across, but before we do that, let's go ahead and factor. Can we factor? Yes. There's a GCF of 7, so when I take that out, I've got x, but now plus 28 divided by 7, which is 4 here. Can we factor x minus 6? No. So I just leave it. So here in my numerator, I've got 7 times x plus 4 times x minus 6. Now in the denominator, I do have a trinomial. So I can go straight to parentheses because a is 1. So now what numbers multiply to get negative 18, to get negative 3, negative 6, and positive 3. Then here I've just got 7. So I'm going to move that value in front as if like before if it was a GCF. So 7 times x minus 6 times x plus 3. So now here as I'm simplifying, I see I've got x minus 6 and I've got 7 divided by 7, which is 1. So the 7s also cancel out because they give you 1. So here our width is represented by x plus 4 divided by x plus 3. That is the width.